problem in our community that we are trying to solve.
We are going to help our community filter water so that it can be healthier to wash your body and dishes in clean water. Most of all, it is so that people in our community can consume clean water and stay healthy. Water filtering in our community isn't a large issue. However, the people in the community do use a large percentage of clean water. Our project is based on being able to keep it clean if the supply of water ever runs low.
Result I would like to achieve: filter water, reduce costs, and make it easier to access the filtration system. Possible solution: a series of filters in a pipe leading to a faucet of some sort, water with debris getting caught through the different sized filters. Once all the debris and bacteria is gone, it will be healthy enough to consume.
Has this been done before? Now, this project hasn't been completed successfully in the past, however similar experiments have been done. This particular project showed that a filter is any device that separates solids from liquids or gases by passing the fluid suspension through a barrier, the filter, which removes all particles above a certain size and allows the fluid and any smaller particles to pass through. The project also showed that a strainer is defined by its purpose to remove unwanted large particles from a liquid suspension, usually to protect some sort of downstream flow, which is showing that the filter and strainer have similar jobs but do it in different ways, leading both to similar and different outcomes.
The materials that we use for our prototype are dirt, water, liquid measuring cups, one large bowl, 3 different size strainers that are large, medium, and small. How do we measure the controlled variables? We use 3 different strainers, each with holes going down in size to filter the water. For every time we test the water, we are using 500 milliliters measured in a measuring glass.
Variables. Our independent variable was the strainer hole sizes. The dependent variable was the filthy water with debris, and the controlled variable was the amount of water and the number of strainers.
Model. Our model contains a filtration system that will filter the water when it enters your house to conserve your water supply. 1. Water would go through the pipes to your house. 2. The water is pushed and forced through the multiple strainers. 3. The soon clean water would make its way through the faucets. 4. Before exiting the faucets, the water would go through another filtration, making it even more clean.
Filter procedure. Gather raw materials. Add water to a measuring cup with 200 milliliters. Add just enough dirt and debris to the 200 milliliters of water to get 225 milliliters. Pour the dirty water through the first strainer while an empty bowl sits underneath. After, pour the water back into the measuring cup and record how much water is decreased. Then clean out the bowl and measuring cup. That way, it's just the same as you started. Repeat all the steps 2 more times using the other 2 size strainers.
For our experiment, we used our 3 strainers varying from sizes big, medium, and small. When we tested the big strainer, all 3 trials ended up only emptying to an average of 200 milliliters. When we tested the medium-sized strainer, the first trial was 190 milliliters, and the second and third trials were 175 milliliters. The average water left over for this strainer was about 180 milliliters. The test of the third strainer, the smallest, came out to be the first trial of 170 milliliters. The second was 180 milliliters, and lastly the third was 200 milliliters. The average of the strainer came out to be 183.3 milliliters. If we were to retest our current design with some changes, we would most likely use smaller strainers, which would most likely end up with different results that would be fairly similar to a real filter. Our current prototype did help clean a significant part of the water. However, smaller strainers would have done the job even better.
So we built a model in a bathroom out of old kid stuff, and it was a filtration system in the back, which also could be in a kitchen or any other place that water runs in your house. But we had a straw to demonstrate pipes in the house, and each of these is a filter, which would be a strainer, and then it leads into the sink, which is in the bathroom right here. So yeah, this is our model, and if you're wondering why there's a guitar, we just felt that it was very necessary. So yeah, that's our model.
How do we measure the controlled variable?
How do we measure the controlled variable?
This project hasn't been completed successfully.
What is the problem in our community that we are trying to solve? We are going to... What is the problem in our community that you laughed that time? What is the problem in our community that we are trying to solve?
We are trying to help our
What is the problem in our community that we are trying to solve? We are going to help our community filter water so that it can be healthier to wash your body and dishes in clean water. Most of all is so that people in community
Possible solutions. As a series of filters in a pipe leading to a faucet of some sort.
I knew that was him.